share that knowledge with us tonight. So, Dr. Bunyard. Thank you, Britt. What? I don't think he wants me in his picture.
Well, we know Photoshop the idea. Let me get a picture. Start.
Oh,
You don't mind, do you, Britt?
What's happening?
Put your arm
He
around.
wants to take a picture of us.
There you go.
There's lots of photos of us.
Yeah.
Just act like your friends anyway, right?
So what I'm about to tell you about Amanitas may have errors, but if it does, it's because of my mentor teaching me. So some quick announcements. If you came in and saw this stack of Fungi magazines, those are freebies. If you're not a subscriber, grab one before you leave. And I purposely chose the fall edition because this one, and you can hear me okay, right? This one featured the breaking news of the newest state mushroom in the U.S., and there's not many states that have a state mushroom. The Texas state mushroom, the Texas star, which is an endemic species of Texas, pretty cool. No, that's right. And you can read all about it in here, and I thought that'd be a good one to bring because I figured it'd be people from Texas here. So that's one announcement. Those are for free. Also, there's copies of the Amanitas of North America book in the back that Jay can sell to you. He can take cash or credit cards. And there's also a few more, or maybe, I think there's a few more of the beginner's mushroom book back there that I wrote. And if anyone wants a copy of that, those are available too. Cover price on those is $25, but they're only $20 here because I was delighted to get invited. The Amanitas book cover price is $60, but they're $40 here. So if you're short on money and you don't even have to have money, you can just give us credit cards. So, any other announcements I should make before we start? Should the lights go down?
Yeah, I'll get him in a second.
It's somewhat embarrassing when you fall asleep and I can see you, so if you want to turn the lights on, that's totally fine. Or if you want the lights left up, that's fine. Okay, so we'll take it away. So tonight's presentation will be an overview of some of the Amanitas of the South to be on the lookout for, and some came in at the foray. So let's take it away. So in this presentation, you'll learn about some basics of Amanitas. This is a group that, even if you aren't so interested in Amanitas per se, it's still a good group to learn right away because they're common, they show up everywhere, and they cause nearly all the mushroom-related fatalities in the world. So if you're the type of person who wants to eat mushrooms, you should know about these as well, so you can keep from poisoning yourself. So we'll look at some of the different groups of Amanitas and a bit about the mycorrhizal lifestyle, some lookalikes of Amanitas. And again, all of this will be from the perspective of a non-taxonomist, because I'm not a taxonomist, merely like an ecological mycologist or a field mycologist, let's say. So it's not going to be too terribly technical, mostly pretty pictures, which is basically the gist of what the Amanitas book is about. Okay, on with the show. So it's good to learn about Amanitas, in my opinion, because frankly, most people that are into mushrooms usually are into Amanitas. They're big and showy. They appear in the middle of mushroom season and are very noticeable, unlike some other mushrooms. They're always brought into mushroom fairs and forays because they're big and showy. And in fact, around the world, there's even parades and festivals and stuff where people dress up like them. The picture of the parade in the middle is from Scandinavia, I think maybe Denmark, where they have a mushroom parade in the fall. And I mean, just look at the people. Whenever people find Amanitas, they're just excited. They don't know why, but it's a cool mushroom to see. In Telluride, where the Telluride Mushroom Festival takes place, the director of the Telluride Mushroom Festival, last year was the 41st year for the festival, by the way. It's the largest wild mushroom festival in North America. If you've never been, check it out. People dress up as all kinds of mushrooms for the parade, and of course, Ammonite Scary is one of the top themes of costumes, but people go as all kinds of other things as well, and it's a pretty wild time. And another thing about Amanitas is all of the mushroom clubs always educate about them because, again, they cause nearly all the deaths related to eating mushrooms around the world, so this is obviously something to be aware of. This photo here is from the Mycological Society of San Francisco's show, and in the Bay Area, Ammonite Phylogenetic is a common mushroom, so there's poisonings and deaths just about every year out there because they are so common and people are into mushrooms. all mushroom guidebooks usually have some sort of a warning at the beginning about making sure you learn about this group of mushrooms first if you decide you want to start eating mushrooms, because again, it comes with some of the most infamous species. Okay, so this is by far the most technical thing of the whole performance, and it's just merely to show you where Ammonitas come from in the whole history of mushrooms. This is a phylogenetic tree, and you can see on the bottom are depicted the branch for the ascomycete fungi. These are things like yeasts and morels and gyrometras, cup fungi, stuff like that. And then the whole top part of the tree are things like basidiomycetes, russulas, Ammonitas, boletes, stuff like that. These two groups of mushrooms in the kingdom of fungi split from a common ancestor about 350 to 500 million years ago, a long time ago. And we saw, or we see in the fossil record, some of the oldest groups that came on the planet first are things like chanterelles and polypores and boletes and suillas. Those are really, really old groups of mushrooms. Ammonitas are with much more recent arrivals in the agaricoid type mushrooms up here. So trichomas and agaricus, Ammonitas, things like this, Cortnarius, these all are much more recent. So these evolved from a common ancestor from all the rest of the fungi about 100 million years ago. So much more recent arrival, so they've been around a long time, and in fact so long that they mostly were in place when all the land masses were together and then split up, and that's why you have things that look like Ammonita muscaria in both Europe and North America, things that look like Cortnarius violaceus in Europe and in North America, because again, the landmass was all together when these mushrooms spread over that one landmass, and then it split, and now you have speciation coming in later on. So if you took this branch, I guess I should back up. If you took this branch that has Ammonitaceae, the Ammonita family, and its closest relatives, the Pleurotaceae and the Pluteus types, these are all most commonly related. If you tease that little branch apart, what you'll see is the most common, the most closely related ancestors or most closely related relatives of Ammonitas are things in the Pleurotaceae. There's that kind of pesky break in the panel right there. That says Pluteaceae. So this is the family of Pluteus and Vulvopluteus and Variola. Lots of Pluteus specimens came in today, and believe it or not, those are close relatives compared to all the other mushrooms to Ammonitas. They don't really look that much like them, but I'll explain how this works in a second. So anyways, if you then look at the family Ammonitaceae, basically it's comprised of one big genus, Ammonita, and this little tiny genus of allies, Limacella, which really isn't worth talking about because they're pretty uncommon and not very many species. Anyways, within the genus Ammonita, the genus is broken down into two subgenera, and those two subgenera are broken down into a total of 7 sections. And the whole point of all this is that there's so many species of Ammonita, lots and lots of species, and it's really tough to know them all, and frankly, probably half of them maybe don't even have names yet. But it's really not necessarily, frankly, to know them all, because you can pretty easily separate your Ammonita in one of the 7 sections. Quite easily. It's not like other groups of mushrooms. You don't need a microscope. There's different colors and large structures, and it's actually pretty easy to do. And with that knowledge, you can go to any sort of a guidebook and pretty easily figure out what your species is in your region of North America, or at least pretty close to it. And from that, you can also determine, this is either a dangerously poisonous species or it's an edible species, etc. It's actually that easy, and that's what the point of this talk is. Okay, so Ammonitas are most closely related compared to other mushrooms to things like Pluteus, which came in today. So several people saw these on wood, and at first glance it's like, oh, it doesn't really look that much like an Ammonita. But if you look at the structure of the cap, how it's shaped, it actually is shaped fairly bit like an Ammonita. It's on wood, it's a wood rotter, which Ammonitas don't do. But the stem looks about like it. The gills look a fair bit like Ammonita gills, but there's one thing about the gills that's different from Ammonitas, and that's the color, and that's because Pluteus produce what color spores?
Pink.
Pink, right, and Ammonitas produce white spores. So one easy way to know the difference, in addition to them growing on wood. So this is, believe it or not, a pretty close relative. And what's going on is that Ammonitas come from an ancestor that was sort of a Pluteus-like mushroom. It was a saprobe, and something happened along the way that caused Ammonitas to lose the ability to break down wood, and they had to figure out something else to do. They became binotropes. They became mycorrhizal partners with trees, most of them anyway. More on that in a little bit. So other things in this Pluteus group, or the Pluteus family, are Variola. Now that's starting to look even more like an Ammonita, right? It has a saccate vulva on it, this big boot down at the bottom. It's coming out of wood as well, and it's also going to have a pink spore print, so the gills will turn pink. Otherwise, it looks even more like an Ammonita. And so in between Variola and Pluteus in this family, the Pluteaceae, there is Pluteus. It's kind of halfway between those two, and it looks even more like an Ammonita. Pay no attention to the mature one on the right that has the pink gills because of the pink spores it produces, and look at the others in the picture. These are a dead ringer for destroying angels, wouldn't you say? If someone handed these to you, you of course would say this is a destroying angel. There's one and really only one difference about this that tells you it's not a destroying angel. What is it?
No attached veil.
No partial veil, no ring.
Yeah.
Otherwise, it's a dead ringer. Even the immature ones look like little Ammonite eggs with their little vulva breaking up here. And you can see there's a saccate vulva on these. But once it gets mature, as the pink gills. This picture was taken at our farm in Wisconsin, where I used to live, and we hosted the Wisconsin Mycological Society annual picnic every year, big bash, like 300 people would be at our farm. And I had the really good fortune, this thing was fruiting in the wood chips right between the house and the big dairy barn where this would happen. And so I put a bucket over top of the mature one. I moved it away, but I left all the others growing still. And so I had a whole bunch of the experts from the club come by and put a name on this thing. And of course they knew it was a destroying angel, but there's no trees anywhere near this. So they're like, how can this happen? Because it has to be mycorrhizal. And then I showed them this one, and they're like, oh wow. And so they still didn't really know what it was. It was some of the non-experts in the clubs that were really old timers, and they saw this like, oh yeah, we used to see this mushroom. Of course, it went by the name Variola Glacefella. We used to see this a long time ago, like back in the 60s and 50s in Wisconsin in farm fields, because they had a different type of plowing technique that left a lot of residue in the field. And this thing would fruit everywhere, and people would collect and eat them sometimes. It's kind of bland. But they knew it, and then it went away when they went to like no-till farming and a lot of spraying and stuff like that. So it's interesting. It's a rare mushroom now. It used to be common as anything. So pretty interesting. But if you saw that, you would swear it was a destroying angel. Perfectly safe to eat. So you can't be too careful. They're definitely lookalikes. So here's a situation, the next few slides, situation where you can have some edibles that look just like deadly Amanitas. So you can't be too careful. The picture up at the top left is a scene also from Wisconsin, where there were hundreds of these Leucogaricus, which is it's a bland edible, but people collect them in the late fall. The common name is the smooth lepiota or the grain lepiota. It's not really a lepiota, but it goes by that name. David Aurora in his Mushrooms the Mystified book calls it Fat Woman on a Bicycle, which I think is one of the best common names for mushroom. Anyways, there were lots and lots of them, and intermixed were some destroying angels. So you can see in this photo, there's some of each. Look how similar they look. So, and in fact, I intentionally picked this destroying angel, much as unwitting people would. They would come along and just grab the mushroom and pull it out of the ground. So it looks even more like the safe edible mushroom because I purposely left the cup of it behind in the soil, which happens all the time. And so this brings up the first point about identifying and collecting Amanitas for tonight's performance. So to identify Amanitas, actually any mushrooms when you bring them into a show like this, but especially Amanitas, you want to get the entire mushroom out of the ground, a little bit of dirt from the bottom, because you could leave behind some important information. In this case, the most important piece of information. And in fact, as we'll see in a couple slides, with Amanitas, most of the important characteristics actually are on the bottom of the stem, not the top of the cap, strangely enough. So if you're the type that cuts your mushrooms all tidy and throws them in the basket, you could be leaving stuff behind that's key to identification. Here's some other edible mushrooms mixed in with look-alike Amanitas that are deadly poisonous. So this is that Pluteus. This is that Pluteus here. This is from California, and growing right along with it, there were lots of these and a few of these. This is the destroying angel of California. You can see how similar they are. And the two mushrooms here are the same destroying angel. This is in Santa Barbara area of California, destroying angels. And this is one of the most prized of all spring Amanitas in California, the spring villosa. The spring villosa Amanita is usually kind of a peach color, but it can be fairly light colored and even white. And if you mistook this one for one of these two, you'd probably be dead, because these are destroying angels and can kill you. The top right-hand corner, those look like destroying angels, but they're actually completely safe edible Caesar Ammonites from Southeast Asia. This is the Ammonite Princeps, and I've eaten it, and it's delicious, but it's pretty freaky when you first pop it in your mouth, because, you know, back here, any mushroom that looked like that would probably be deadly. So this same mushroom, Ammonite Princeps, is probably why so many Southeast Asian people moving to the New World, and especially Hmong people from Laos, are poisoned by deadly Ammonitas. Because our Ammonitas here that are deadly look just like this super common Caesar Ammonita that fruits about half of the year in Laos. And a lot of books will say they are probably mistaking it for paddy straw mushroom or something like that. That's probably not true at all, because first of all, they don't grow paddy straw mushroom in Laos. In fact, they don't really grow much of anything. Laotians forage almost all of their food, almost all of their meat and herbs and mushrooms and things like this. And they certainly don't grow paddy straw mushroom, but they do love Ammonite Princeps. So it's common to see it in the markets. The one on the right, strangely enough, that looks like a destroying angel, that's Ammonita ovoidea from Italy, which is a common edible, and it's also another dead ringer for a deadly mushroom, but it's totally safe. Pretty strange. And I've eaten that one too, it's good. Okay, so how do you know when you have an Ammonite? Pretty simple, and also you don't need a microscope. Ammonitas have, for the most part, large showy structures, and pretty much all the structures. You know, some mushrooms are pretty much vanilla and kind of boring, like Inosebes and Melanoleuca and some other things. Don't have a whole lot of features, so it's tough to figure out what you got. Ammonitas have most of the structures, and a lot of them are colorful. So here's sort of the definition of Ammonitas. They have a white spore print, a white or pale colored gills. So like the Caesars typically have yellow colored gills, some of them, and if they are yellow, they're pale yellow. They all have a universal veil. That's this covering that covers the entire mushroom when it's starting out as a little baby mushroom. And they typically call this an egg, the egg stage, because it looks like a little egg. It looks like a puffball. So in fact, this is the second tip on mushrooming and Ammonitas for tonight's performance. If you are the type that likes to collect puffballs for the table, which I don't know why, because they're awful, but if you like to collect puffballs and you slice your puffball in half, and it's pure white on the inside and it's solid puffball material, I mean, it's totally safe to eat. If it's any other color but white on the inside, it's probably not good to eat. Either it's over the hill, or maybe it's a different mushroom. So if it's like purple or black on the inside, it's probably a scleroderma, which can be poisonous. If you slice your little puffball in half and there's a mushroom inside, that means it's either a stinkhorn, which you can eat stinkhorns, I don't know why you would, but you can, or it's a baby Ammonita. So this covering here is called the universal veil. And as the mushroom matures and expands and gets taller, it will break that and leave the bottom part that's left behind will form the cup. The top of the universal veil that's left behind on the cap, if it's left behind, will leave behind scales or flecks or maybe one piece or whatever, and that's how that got there. Then the other thing about the Ammonitas is they have a partial veil, which is the covering of the gills. That's on the inside here. And as the Ammonita cap matures and expands and opens, the partial veil breaks and reveals the gills and may or may not leave a ring on the stalk. So even the vaginate section of Ammonitas, the ringless Ammonitas that do not have a partial veil, do not have a ring, they do have a partial veil. All books always say they don't have a partial veil, but that's actually incorrect. They all have a partial veil, it's just that it stays stuck against the side of the stem. I'll show you how that works in a second too. Anyways, these are all the features, and of course you know about gills and stalk and ring and bulb, etc. Okay, so we head out into the woods, and if it's a good season, down here in the south, this is a scene you might find after just a few minutes in the woods. Lots of Ammonitas, and the other thing you'll notice is that they're all different colors and even different shapes. So unlike most groups of mushrooms that are all sort of about the same color, Ammonitas can come in all sorts of colors, which again makes it pretty easy to figure one from another. So, and then just to revisit this notion about collecting the entire stem. The reason this is so important is because the base of the stem can be bulbous shaped. There can be a big saccate bulb at the bottom. The vulva could be kind of flimsy and break apart into pieces, like on these guys. The vulva may not form a boot at all, may just be rings of material. On this specimen here, Ammonite is like this. Or it could be just powdery material on a big basal sort of root-like structure. Or maybe nothing at all. So there's a lot of information that comes from the base of the stem. If you're used to just seeing a mushroom from above and making your decision on what it is, with Amanitas, you need to get the whole thing. Okay, so why do they have scales and this business of the ring and all of this sort of stuff? It's because of how the mushroom develops. In each of the different sections, these structures can come about by a different way. So as an example with Ammonita muscaria, it's in section Ammonita. You can see the reason it has a big fat basal bulb is the little baby mushroom, the egg, starts maturing and elongating. It doesn't elongate, the stem doesn't elongate uniformly. It elongates from pretty much at the top of the button, forms a long stalk, but leaves a lot of the button behind and results in this big fat basal bulb. The universal veil is green that covers the whole mushroom. When it breaks, it leaves behind pieces on the top as well as some pieces here on the side, the rings. Whereas if it's something like section Phylogenetic, a lot of it's left behind here, leaving a cup, and maybe one little piece or no pieces on top of the cap, etc. So this is why Amanitas have the look that they do. It comes from the development in their little tiny button. So more on that in a second. Okay, I mentioned that the genus Ammonite is divided into 7 sections, but it's first subdivided into 2 subgenera. The 2 subgenera are the subgenus Ammonita and the subgenus Lepidella. This is based on a couple of aspects. The one real obvious one is whether or not the cap has striate margin. That means there's lines on the margin of the top of the cap. And I'll show you pictures of what that means in a second. Anyways, in subgenus Ammonita, there's the section Ammonita, which includes things like the panthers and Ammonita muscaria. There's section Caesarea, which includes the Caesar Ammonitas, real gritty and showy and all edible. And section Vaginati, which also are all edible and look very much like the Caesars, but they don't have a ring on the stem. And then subgenus Lepidella, there's the Amidellas, which is kind of an odd small group. Another small group is section Phylogenetic, but is important to know because it includes the deadly Ammonitas. Section Validity, which includes kind of a grab bag of a number of different things, but includes the Ammonita lavingula, which we saw a lot of on this event, and then section Lepidella, these kind of big honking things with big roots and big basal bulbs and stuff. That's kind of a cool group. So I'll point out some of these from the south as we go through this. But again, just to show you just how easy, in general, it is to figure out which group your Ammonitas belong to. There's a key like this. This comes from David Aurora's Mushrooms Demystified book. Basically, when you look at the top of the cap, does it have a striate margin or not? As the mushrooms age and dry down, they can start to look striate even if they're not truly striate. So you need to be looking at fresh specimens. If they have a striate cap margin and they have any sort of a saccate vulva, then they're either a Caesar, which has a ring on the stem, or they're Vaginati, which has no ring on the stem. No saccate vulva, then it's in section Ammonita, which means it's Ammonite muscaria or one of the panthernoids or one of the Gemata types. So if there is no striate margin, but it does have a saccate vulva, then it's going to be in section Ammonitella. No saccate vulva, it's saccate vulva, it's Ammonitella. No saccate vulva, it's Lepidella. If the appendiculate, if the margin of the cap is appendiculated, not material hanging off the side, that also will help you determine which of the 4 groups here. Phylogenetic has a saccate margin, and Validity does not. So anyways, it's fairly straightforward to figure out which group you have, and in any region of the country, there's not that many species that belong to any one of those groups, with the exception maybe of Vaginati. Okay, so first section of importance to look at is section Ammonita. This includes things like Ammonita muscaria and close relatives, and panthernoid types and gematoid types. All of these should be considered toxic. I know some people collect them and eat them for purported psychedelic purposes, In my opinion, this isn't a really good group to ingest for psychedelic purposes, just because they are toxic and you'll get sick, and I think best case scenario, most people just fall asleep, and that's about it. For psychedelic purposes, I am a much bigger proponent of psilocybe, and if you want to hear about psilocybes, we can talk some other time. Or just Google my name and the word psilocybe, you know, obviously plenty of stuff about that. Okay, so again, just to recap, Ammonite muscaria and things like muscaria, persicina, pantanoid types, they all have a basal bulb that's very noticeable, and this is why, because when it starts out, there's this eccentric or off-center development of the stalk. It elongates from the top of the bulb and leaves a lot of the bulb behind, resulting in this big fat basal bulb. And there's patches on the top of the cap and a couple other obvious features that helps you figure out which ones you have. Okay, so sort of the poster child is, as Jay always calls it, the poster child of all mushrooms is Ammonite muscaria, the red form from the west. Of course, I grew up in the east, so Ammonite muscaria to me looks like this guy here, the more yellow form, Ammonite muscaria variety Jasoi. This is mostly yellow, maybe a little orange at the central part of the cap, the disc, and has these big showy scales. The margin of the scales, as well as the margin of the ring, will have a yellow color. So you can see the ring here, big honking ring. It's white, but the margin of it's yellow. And that's because that was attached to the universal veil, which was mostly yellow when this was developing as a little baby. And then, and so you have this mushroom here. Further down in the south, and not in the upper Midwest, you'll have this other one, Ammonita persicina, which several of them came in this foray. This mushroom used to be called Ammonita muscaria variety persicina, but as Jay mentioned the previous day, this was elevated by Ron Tullis to its own species. And again, species of Ammonita muscaria, varieties of Ammonita muscaria, it's still not totally resolved, so this is subject to change. But anyways, the difference mainly between persicina, this sort of peach-colored or apricot-colored sort of muscarioid type, is that its color is more peach-like. It's not yellow and it's not striking red like the one on the west coast. In general, there's one other to mention. This is the European Asian Ammonite muscaria variety muscaria. This is important to mention because this is a widely ranging, highly invasive species all over the world right now. In fact, it's even in North America. This is getting to be pretty common in parts of Alaska. It's known from a population in California and also from Massachusetts. So this mushroom is probably coming your way. It's all over South America now, all over Australia. It's moving around with different types of pulp, tree stock and horticultural stock, and then when it lands, it takes over and hops onto other native species. So be on the lookout because this is coming your way. If you go to Europe and you see Ammonite muscaria, this is the variety that you see. And it has sort of a slightly different red to it than the Western Ammonite muscaria. Anyways, the thing about the muscarias is the color doesn't really make the Ammonite muscaria. Ammonite muscarias can be red, yellow, white, and colors in between. All three of these are Ammonite muscaria, variety Flavivulveda. But what makes Ammonite muscaria is has the basal bulb, has the 3 or so rings of velar material above the basal bulb, and then also has a striped margin. So, and the margin is not strongly striped, so it's just striped just here, a little bit of the way into the cap. You can see these also are striped, but there's a lot of material here kind of hiding it. So it's always exciting if you can find all 3 colors at one time, rather than just the yellow or just the red. Okay, so within this same section are the pantanoid types. They don't have several rings of velar material on a basal bulb. They typically have one single, really well-developed ring. It's so well-developed it forms like a collar, or it's called a cothernate stalk. And the other evening, Jay was pointing out this Suillus cothernate that has this collar on it. So these guys have a collar. This is from the west coast and is a real pretty brown. From the east, the pantanoid types get more lighter color. So out in the east where I'm from, this is what our panthers typically look like, a lighter color. But you can see on all these, there's this really prominent single ring collar, cothernate collar, and it's attached to the base here. When I saw the Suillus cothernata back there with its collar, it's not really attached to the base, it's kind of up the stalk. So I didn't think it's really a collar, it's more like a dicky. Wouldn't you say? Maybe that Suillus cothernata should have a better name, because it's more like a dicky, wouldn't you? Agree? I don't think he is. It's like a little false calling. Okay, so anyways, the thing to look for on the panthenoid types are, look a lot like the Muscarius, but they all have this very prominent collar and a basal bulb. Up in the east, we have quite a few species of gematoid and panthenoid types. Kind of hard to tell one from another, but it's easy to know that they're in this section. Down here, I don't know how many you have, but it's probably just maybe a couple to look out for. Again, all of these are considered toxic, and the panthenoid types are considered more toxic than the Muscarioid types. The Ammonita gemata group type mushrooms, the same thing. They, for the most part, their basal bulb looks the same as the panthenoid types. Okay, moving on to the Caesar group. I really like this group there because they're so beautiful and showy. Most are quite colorful, including their gills. Some are completely white, but a lot of them are colorful. And this includes the most popular edible species of Ammonita. So this is, I lost track. This is either like the third or fourth thing that you usually learn from mushroom clubs when talking about Ammonites. They usually implore you, don't eat any wild mushrooms raw because they can be hard to digest, and don't eat any Ammonitas really ever. Which is kind of, it's good advice, but at the same time, the genus Ammonita has more species that are edible and collected as food than probably any other genus of mushrooms around the world. So if you go to South America, Africa, Southeast Asia, certainly Europe, when it's mushroom season, you'll always see Ammonitas in the market. Everyone loves to eat them. We're still a little worried about them here, but people are starting to get educated and change. On the West Coast, there may be a little bit more head and eat a number of Ammonitas, including this one here, the Cocora. But if you go to Europe when it's mushroom season, you'll see lots and lots of mushrooms in the market. Everyone knows Italians are crazy for the porcino, which is a big honking edible bolete mushroom. The porcini mushrooms don't fetch nearly the price that Ammonita muscarius do, especially in the button form, the egg form. You can see the price there, 50 euros for a kilo. So that's 50 euros, that's more than $50 for 2 pounds. That's far more expensive than king boletes. And the other thing about Ammonitas is not only do they break one of the club rules about not eating Ammonitas, they break the other one because the way to eat Ammonitas, at least Ammonita Caesar types, is raw. If you cook any of the Caesars, they kind of fall apart and don't have a lot of flavor. They're typically eaten raw. They're very aromatic and firm, and it's just about one of the best mushrooms that you'll ever eat. Has anyone here ever eaten Ammonita ovule? Yeah, it's one of my favorite of all mushrooms and the way to eat it. It's simply raw Ammonitas, especially the eggs, sliced kind of thin over top of a very simple salad with just olive oil, lemon juice, and of course salt. That's it. It's extremely aromatic. It's also a really good way to eat very young king boletes too. A porcino mushroom that's small, really firm, you can shave with a truffle shaver. That's the way to go for it too. Of course, don't eat too much because it is a lot of fiber. It's like eating lots and lots of apples or any other fruit. There's a lot of indigestible material there. Otherwise, it's totally safe to eat. So in the east, our main Caesar, Ammonite jacksonii, looks really similar to the European Caesaria, as they call it over there. And for the longest time had the same name. Out of the West Coast, there's some species that look a little different. They're more bronze colored like the Cocora, and then the spring Cocora, which is Ammonita vernicocra. It's a much lighter color. But both of those are big and chunky and very popular edible wild mushroom and some of the best mushrooms around. So the thing is with the jacksonii, our eastern and southern Caesar, it looks nothing like any dangerous Ammonitas. You wouldn't confuse it with anything. The spring Cocora on the West Coast, this guy here, it's a pretty light color, so you could confuse it with the death cap. Having said that, I've eaten it numerous times. In fact, this was a batch I was serving up for members of the Los Angeles Mycological Society at a party, and they were all pretty squeamish, as you can imagine, because they saw mushrooms there. And Gary Linkoff took that photo of me, and of course Gary was screwing around by like whispering really loudly in the kitchen, "Britt, are you sure about this one? I'm really not sure." And of course, when Gary says he's not sure, there's all these heads are peeking around the corner. Like, don't worry, just don't be the first to taste it. And of course, it was all fine, and no one got ill or anything. We all thought it was great. least that's what I'm gonna tell you. But, certainly things can happen. So this picture here, this is even, I like this picture so much, it's even in our Amanitas book, because this shows you just how hard it can be to tell, even for experts. So in this picture, there are absolutely deadly death caps and absolutely delicious spring pecoras, which were eaten, by the way. Can you tell the difference? Pretty hard to know. David Lewis, would you eat any of these mushrooms?
The one, that's the one on the right, and the one left, center. Because the other two have green in them.
Okay, which ones, what's this one? Good, bad?
Good, bad, good, bad, good.
You sure about that?
No, not really.
Do you want to call Jay on the lifeline?
What?
Jay, what do you think?
Okay, the one on the far left's phyloides, it doesn't
Yeah,
have
I see
the
that.
development material on top of the cap. The one right in the middle, I mean, the next one, yeah, that's phyloides.
That's what I said.
Well, okay,
So-
no,
so
yeah,
that's-
yeah, I see it now, I see
So wait,
it.
what's this up here?
Yeah, well, it's stuff that phyloides picked up. No, it's okay, looks like the one maybe on the far left in Britt, maybe.
And so this brings up, so yeah, David Lewis was actually totally right from the start. But this does bring up point number 6 or 7 that clubs always teach you. When in doubt,
Throw it out.
throw it out. Yeah, it's not worth dying for. Even though these are really so good, it almost would be worth it. Almost. So in the Amanitas book, Jay and I put together, he informed me when we had to finish that it took us 8 years. I lost track. It took us a long time. Anyways, throughout the book, there are a number of Easter eggs. And this was one Easter egg for our very good friend Steve Trudell, because Steve Trudell said there's absolutely no way you could ever confuse phyloides with Variola because they don't occur at the same time of the year. And he also famously said there's also no way you could confuse them because phyloides never has a skull cap on top. So in the book there's several pictures with phyloides with patches on the top. I purposely didn't put them there because they sometimes do.
Yeah.
So whenever you say always with mushrooms, any absolutes with mushrooms, you're gonna get in trouble because they break all the rules. That Lactarius that came in that was like aborted.
Mm-hmm.
I mean, any foray, you find stuff that breaks the rules.
So what does a death cap taste like?
Oh, so the question is, what does a death cap taste like? So death cap tastes absolutely delicious. And this is part of the reason why people get poisoned. So, you know, unlike a lot of other organisms in nature that are poisonous, it's not really wise enough simply to be poisoned and off-putting to things that might eat you. Because you still could get bitten and damaged and maybe even killed. It's wiser still to advertise the fact, not camouflage yourself, but advertise the fact that you're dangerous and have bright colors, especially reds and yellows. This is so common in nature in plants, animals, like every group of organisms except for fungi that evolutionary biologists call warning colorations, aposematic colorations. And, you know, coral snakes, red touches yellow, kill a fellow, red touches black, friend of Jack. So these color combinations, they warn of the presence of toxins, and typically organisms leave them alone. That doesn't happen in fungi. There's really no poisonous red mushrooms that I know of in North America, or yellow ones really. Most poisonous mushrooms are drab colors like white or brown. They also don't have, the deadly Amanitas anyway, don't have bitter taste or foul smell or off-putting smell to warn you that what you're about to put in your mouth is poisonous. They actually taste very good. And it's, by the way, it's totally safe to handle any mushroom, including death caps. It's totally safe to smell it. It's totally safe to take a bite out of it, you know, small bite, and then spit it out, of course. I mean, you wouldn't want to be dumb, but they taste absolutely wonderful. So there's no indicator. It's not like the bitter bowl eats that even when you're cooking them and after you serve them, they still taste horrible because they're still bitter. Amanitas actually taste really wonderful, even the deadly ones. Yeah, as they get really old, they can take on a fishy smell, but when they're fresh, they taste really wonderful.
So before you move on, can you explain to us, other people, newbies, why how you can tell the difference here?
So the difference is super subtle, and there's no way anyone, even experts, really should fiddle with a situation like this just because they do look so similar. How Jay and David Lewis, who've all seen like millions of mushrooms, how they could tell is, first of all, I told them there's phyloides and vernicocras and stuff. Okay, having said that, then this one here and this one here both have more of a greenish color.
Okay.
That's typical most of the time with phyloides. Phyloides can be completely white though, and cream color. It can be real bronze color. It's usually this color, but it can vary. And then the vernicocra has this chartreuse color. And also, if you look closely, the vernicocra has a striate margin. Can't really tell so much in this photo, but it's there. Whereas the phyloides don't have a striate margin. So there's a few things, but this is one of those situations where you still wouldn't really want to take a chance if you weren't absolutely sure. So there's some other ways to know. So with the Caesar Ammonitas, which are the most popular edible Ammonitas, other than the vernicocra, most of them are brightly colored and have a brightly colored stem and this white saccate vulva and a striate margin here. But even if you didn't have all of these features totally intact or weren't really sure, there's still one more way to know, and that is even the little baby egg. This is another parade costume from Telluride, by the way. They're pretty cool too, really nicely done costume. So if you slice them in half, Phyloides type Ammonitas are solid on the inside, and Caesars are hollow. The stem's hollow. And when they're really young, this hollow is even kind of like a little jelly, kind of weird. And so this is an Eastern Caesar, obviously. It's really pretty, that striking orange color. Who wouldn't want to eat a mushroom that looked like that? That looks awesome. Okay, so, and the final Caesar to show you is, they're not all great big and honking and colorful. Some Caesars you might overlook, and some vaginatas you might overlook because they're so Lilliputian in size. There's a little tiny vaginata that came in, I'm sure no one was even gonna look at it, and I rescued it off the table back there. It's up here somewhere. It's a super tiny little vaginata type, and you'd only know it if you busted open the soil at the base and could see it had a little tiny saccate vulva. But anyways, these are two of the smallest Ammonitas known. The big picture there is from one that you should know from down here. Look how super tiny these are. These are in centimeters and millimeters. These are fully formed. They have a little saccate vulva, a little ring. They're producing spores and everything. This is Ammonita virginiana. And this is an eastern one, Pachyspherma. They're the smallest Ammonitas. They're super tiny. No one ever sees them. The other weird thing about it is the tiniest Ammonitas have the biggest spores. Ammonite Pachyspherma has the largest spores of all the Ammonitas, even though it's the smallest.
Is there an evolutionary benefit to that for them?
I don't know, but what it tells me is that big things can come in small packages. So if there's anyone that's height challenged in here, don't let people push you around because you could have, I guess, very large spores or big ideas or something. So, yeah, I don't know any advantage to being small in size or producing large spores. It's just one of those things God did to make us bewildered, excite us. Okay, so next section, vaginating. This is a favorite group of mine because they're very pretty. Some of them are quite large. But also, there's just so many of them, and probably most of them don't even have names yet. This is the group that the Ammonitologist of North America, Tullis, is most busily working on right now. This one here is from the east Tawny Crescent. I see it all the time up in the north woods. It occurs in kind of swampy areas. It's really pretty. But there's a bunch from down here in the south. And just to recap, these don't have a ring on the stem, but they still do have a partial veil. So when it's developing, where's my, oh. When it's developing, there is a partial veil that goes between the stalk and the gills, and when the cap opens up and expands, that partial veil, instead of snapping open and forming a ring, it actually stays, so this is the partial veil in here, stays pressed against the cap. In some white species like these grisettes here, you can't necessarily notice it so much. You can tell there's material on here, kind of like a snake skin, but it's white, you can't tell. On some other species, you can tell. Things like this big honking dude here, the velvet material is brown. By the way, if this, so this is from the West Coast. If anyone wants to know what a saccate vulva looks like, that's a saccate vulva. That's a boot. But a lot of other ones, the vellum material will be gray and form like a snake skin like this guy here. This is the snake skin grisette. Ammonite Princeps and Texas Aurora are from down here and form these really pretty stalks. The vulva is kind of crumbly and falls apart, so it doesn't form like a real big boot, but they can have these really pretty chevrons and things on the stalk. There's some of the ones from the north have bright colored orange fibrils, and they can be quite pretty because of these showy bits of material on the stalk. This guy here, Ammonite Justicii, which I don't know for certain that I've ever actually found. It's named for J. Justice. Justice is ringless Ammonita. And since I don't know much about it, I actually have to get the book out. Hold up.
Quiet. Britt.
What's that?
Nothing. How do you not know about it?
So this is not a very well-known Ammonita, right, Jay? I mean, I've probably seen it, but I didn't know what it was. So anyways, but it is in the book, so I'll have to read to you, which will kind of give you a flavor for how the descriptions go in this book. So it says, Ammonite Justicii was first discovered in Missouri and has been reported from New Jersey and North Carolina. It seems associated with hardwoods such as oaks and hickories. This species differs from most other members in this section in having an umbo. So an umbo is the bump at the top of the cap. Not many Ammonitas have that. But this umbo is even more special still, and I'll tell you why. So this species differs from other members in this section having an umbo of hard, dense flesh, unlike other Ammonitas. Ammonitologist Rod Tullis has noted that the hard umbo on some species reminds him of the perforatoria that are present on certain species of Termitomyces, and that permit those mushrooms to push up through very hard, packed soil when they're coming from nests of termites. Has anyone ever heard of Termitomyces before? They're pretty cool. Anyways, it goes on and says, members of this group, the Penetratrices group of the section Vaginati, have this umbo. There's not many species in that group. So this is kind of a special mushroom with kind of a special growth development and habit, which I think is pretty cool, and hopefully we can learn more about. So then there's one other little note. Every species we have in the book, they have like 200 species in the book. Every single one, we tell you where the name comes from, you know, what it means or whatever, which there's only a few other books that I have on other mushrooms that do that. I think it's kind of a neat thing. So this one says, the species is named for amateur mycologist J. Justice. He's sitting right there. A co-author of this book. Odor ranges from absent to slight to foul. No taste reported of the mushroom, that is. Because we always say whether the mushroom has a taste or an odor. Sorry. It's okay that I wrote that, right? You knew I wrote that. So anyways, that's about this mushroom, which, again, there's not much known about it. Not many people have seen it. So be on the lookout for this dude, because this is something that scientists definitely want to know about. If you want to know more about these Termitomyces, here's what they are. So in Eastern Africa and Southeast Asia and Western Australia, again, all those land masses were all together at one time, and Termitomyces evolved, or I should say co-evolved. They co-evolved with their termites hosts, and which is an amazing similar story as Attine ants of the New World. So this is the old world. Attine ants with a type of like a Lepiota type mushroom that they cultivate. These termites cultivate this guy. And it's really weird because, you know, termites, if you've seen them, they look a lot like ants. They're extremely distantly separated evolutionarily. Termites are very, very primitive insects. Ants are very modern insects. But they've evolved a really similar looking look, a similar morphology, and in some cases a similar lifestyle. They cultivate fungi. So the termites in this genus, genus of termites, cultivate Termitomyces fungus. They go out in the forest, clip all kinds of plant material, bring it underground, grind it up, and grow these gardens under their nest. This is a great big giant nest, this big giant pile of dirt that's probably 6 or 8 feet tall. They grow these gardens underneath where they feed the plant material to the fungus, and the ants, the termites, eat nothing but the fungus. They no longer have the ability to digest plant material. The fungus has to do it for them. They eat nothing but the fungus. In fact, there's certain amino acids and things they can get nowhere else. They have to eat the fungus. The fungus no longer has the ability to live without the ant because it gets certain nutrients that the ants put into these gardens, believe it or not. The fungi do fruit sometimes and make spores, and when they come bursting up through the soil and mature, you can't really see it on these mature ones here, but on the young ones popping up, they have a perforatory. That's what Rod Tullis suggests that this Ammonita justicii has this bump on its cap for us, pushing up through soil. Does everyone know about these termitomyces and termites? It's an amazing story. And here's a picture of what their gardens look like. If you don't know about stuff like this, but you're fascinated, here's another shameless advertisement for something. Next spring, I'm coming out with a book that has all kinds of bizarre stories about fungi and their symbionts and their pathogens and their lifestyles and stuff. It's coming out from Princeton University Press. This is the book here. But in any case, don't look at that, that's the ad. This is the artwork from the book, which shows how this works. These push up through the soil because they have this hard perforatory on the top. The stalks of these things can be several feet long because these nests are far underground, and this is what they look like. This is all fungal material. That's the only thing that the termites eat. Isn't that amazing? And it's amazing that it's evolved more than once. It's hard to believe it could happen, but it's evolved more than once. Pretty cool. Okay, so a brief mention of the Phyloideae, and then I'll show some Lepidellas, and that's unfortunately the end of the show. So this is a group that you definitely should know about because they're the deadly Ammonitas. So again, the death caps never have a skull cap, except sometimes they do. And then they range from very light color, greenish, but they can be much darker. They always have this white saccate vulva at the bottom. I don't know that they're this far inland on the Gulf. So far, they're only known really from the west coast and the east coast. They came into North America from Europe, a few decades ago, but they've been moving inland at a rapid clip. So why are deadly Ammonitas so toxic? So mention the muscarias and the panthenoid types being toxic. They have a different type of toxin that's not dangerously poisonous. It's not deadly. The members of this section are the only ones that have this alpha-manatin, although some other non-Ammonitas also produce this, like Galeritis. This compound, alpha-amanitin, so this big compound here that the mushroom produces, nobody knows why it produces it. It's toxic to mammals for sure, maybe some other animals, but that's about it. It kills humans because it blocks the transcription of messenger RNA from DNA by blocking RNA polymerase II enzyme, and when you shut down that, it shuts down cell division, protein synthesis, and all those sort of business. Typically the liver is targeted the most because that's the organ that detoxifies the blood, plus as this compound circulates through the blood, the liver gets several doses. You don't die from the toxin necessarily, you really die from having a liver that's destroyed, no longer can detoxify your blood, so you die from a buildup of your own natural toxins over several days, unless you get a liver transplant. And it's a pretty gruesome way to go. Anyways, this mushroom causes about 90% of all the mushroom poisoning deaths in the world. In total, mushrooms from this group cause, nearly all of the deaths. There has been a test for this toxin called the Whelan test, or the Meixner-Whelan test, or the newspaper test. Basically involves squeezing the juice from a fresh Amanita onto old-fashioned newspaper, and then drawing a circle around these spots, and then allowing it to dry. You have to draw a circle because it'll dry and it'll vanish. So once they're dried, and then squeeze the juice of another mushroom or no mushroom someplace else and make a circle. Then you drop drops of concentrated hydrochloric acid on there, and in a few seconds, you'll see a bright blue color form if amatoxin is present, usually. It doesn't work that well. Sometimes the blue's hard to see. Sometimes blue happens as a false positive, so it's not the best test. Jay, you've done this test, right?
Yes.
It's kind of subjective to the person doing it. It's kind of a pain, and that's not real accurate. And in case it takes a lot of material too, it takes a lot of juice. So it's only really useful for mushrooms. You can't test blood or anything. Well, lo and behold, just a year or two ago, a scientist at the USDA in California, Candace Beaver, developed a test that's an antibody test, kind of like a pregnancy test. You see it here. And it's incredibly sensitive. It's so sensitive that, and we're going to do this test tomorrow on some Ammonitas, so come to the table talk tomorrow morning, you'll see it. It's really, and you'll be able to do it yourself. It's really cool to see, and it's so sensitive it can detect nanogram amounts of the toxin. So you can detect the toxin in a victim's blood or urine. So, and it's astoundingly accurate. In fact, it's so sensitive that, as you'll see, it's easy to get false positives if someone handling the mushrooms also handles the test. And that's happened. So in any case, really, really cool to do. We'll do it tomorrow morning. So destroying angels down here in the south are all white, like this big group here, probably Ammonita subaliacea. Most books list Ammonita bisporigera as the deadly destroying angel. This is probably not as common, and it's actually a typically really small little guy, so probably other destroying angels are the ones that people would get poisoned by if they were to get poisoned. And sure, for sure some destroying angels came in, so you want to check them out. In any case, that's what to know from that section. The last section I'll show is just a few pictures from this section, Lepidella. And if you're in the south, you have to talk about this group because in the Pacific Northwest or the Midwest or the Northeast, there's not many species in the Lepidella section present. Southeast has tons of them, and it's my favorite group. They're usually really big, massive mushrooms, a lot of them easily over a foot tall, and a lot of times, like this big group here, Ammonita Princeps, have like these big giant roots underground. They're really cool to see. And here's one now. So this is Ammonita Dossipes. Dossipes, this is named because it's the carrot foot. It has a big root that looks kind of like a carrot or turnip, and it's orange colored. It says here, Ammonita Dossipes of the South, and J. Justice also of the South. So as I often am, I'm his gear hauler, his Sherpa. On this rainy day, I was his umbrella boy while he was taking very crucial scientific photos and data, and I was there holding the umbrella like his porter. And he's like, oh, wait, quick, take a photo. Okay, now get back in here, boy, with that umbrella. So really nice specimen there. If you have photos of J. Justice in the woods, he's often holding volutes or Ammonitas. But it doesn't stop there. The Lepidellas can have all kinds of different situations. They can have big scaly caps or basal bulbs, or they can be very powdery. So Ammonita polycramus has a scaly bulb, but very powdery. The stem's powdery, the top of the cap's powdery. The ring underneath, you can't see it here, but it's powdery. And then other times the scales on some of these can come off, and sometimes the scales are integral with the cap and they don't come off. They're part of the cap. So this group has a lot of differences from all the other groups of Ammonitas. And then there's even some that have scales on the base of the stem that are recurved. So they come up and they kind of curve back. They're really neat to see. So for mushrooms that are all white, like almost all the members of this group are, they're really impressive to see just because of their size and all the different structures of them. And didn't you send me this photo, Jay?
I think, yeah.
Yeah, so it's a close-up of Ravenelli. It's another great big giant, massive Ammonita. It can be easily a foot tall, a great big fat root, like the size of an apple. And then they have these really neat shingled scales on the top of the cap. It's really impressive to see. And so how they form is depicted here in this illustration from our book. But one other thing is shown here is that when you look at these guys, they always have, or almost always have, material hanging down from the side of the cap, this velar material, and that's called an appendiculate margin. If you see these dudes here, there's material hanging down, of mature caps, material hanging down, and that's nothing. Some of them, the material can hang down inches. It can be like hanging off the side like curtains. It can be really, really impressive. There's some pictures of them displaying that in the book. I don't have any here. I'm not going to show you all the pictures from the book because then you won't buy the book. But suffice to say, they can be really impressive. And in this group, this is the oldest group of Ammonitas. In this group are some things that have posed conundrums. Problems. They've posed problems to scientists because you can see them, like this guy here, Ammonita tiercii, away from trees. If you have any old mushroom guidebooks, when it says Ammonitas, it'll say, you know, with trees, with this tree, that tree, whatever. It never says any of them having anything to do in a situation where there's no trees. We now know that that's not true. There are a few species that can fruit without the presence of trees. And how this happens was only confirmed just a few years ago, amazingly, even though these are really common mushrooms. And what's going on in here is they are actually saprobic. Some of these members of the Lepidella, the oldest species of the group, actually are saprobic. They are not biotrophic. They do not form mycorrhiza with tree roots. And it's thought that they are a basal group of all the Ammonitas. Ammonites come from saprobic species, somehow lost the ability to break down cellulose. In fact, that's known too. This guy, Wolf, who studied in Pringle's lab at Harvard and then at University of Wisconsin-Madison, looked for genes to break down cellulose. It turns out there's 3 gene groups to break down cellulose, and these oldest Ammonitas lost through mutation 1 or more of the genes to break down cellulose and no longer can do it, so they had to figure out something else to do. They became symbiotic with trees. They became mycorrhizal. And it also turns out many of the mycorrhizal Ammonitas still possess 1 or 2 genes to break down cellulose. So it's possible they can derive some nutrition kind of saprobically. And scientists are even finding a lot of other mycorrhizal fungi too, brushulas and boletes and things, also possess some ability to break down cellulose, believe it or not. Kind of cool. So more to the story I'm sure is coming. Anyways, this is Ammoniters, one of my favorites to see. Great big giant mushroom that occurs on lawns. It seems to be moving further and further north. I mentioned this mycorrhizal thing, so I have one last slide here to show you. If you're beginners, because I saw a lot of hands the other night, so I thought I'd throw this in here. So mycorrhizal fungi are probably most of the mushrooms that we usually get excited over: boletes, chanterelles, Ammonitas, etc. Mycorrhizal means these are partners with tree roots in the forest or around your home. When you see them coming from the soil, you pick them, they're not actually coming from the soil. They're not rotting things or anything like that. They're growing from the roots of trees. You know, when you took high school biology, you were taught that fungi break down stuff, and that's true for some, but the vast majority of fungi do not break down material. They do not decompose. They are pathogens or they are symbionts with trees. The trees absolutely have to have the fungus because it does most of the work for the tree. And likewise, those fungi have to have the tree because that's where they live on. So you can see here from this little seedling of a pine tree, the roots of this little seedling extend out right to here. That's where the rootlets stop. All this stuff is not root, that's fungus. That's fungus of a mycorrhizal fungus that's in the soil that's basically invaded, almost like a parasite, invaded the roots of the tree, grows out into the soil, and that's what brings in the moisture and a lot of the nutrition and nitrogen to the tree. And so what's the fungus get in return? The fungus gets photosynthate from the tree because it can photosynthesize and create all kinds of carbon-based molecules that then are passed over as building blocks to the fungus. Pretty cool situation. One has to have the other. And it's usually a fairly specific thing. So I mentioned that's the last slide. So the book has, the book project we did has lots of photos from a number of people that helped us out. In fact, some of the photos I showed tonight are from people on this list. But I definitely have to thank my partner in crime on this. So, a great Jay Justice. You know, around the country, there's a number of different mycological societies that have, you know, like that one person that's maybe the expert that really does like all the work for the club, identifying stuff. But you may or may not know, you know, what a treasure Jay is for this part of the country. I mean, he's renowned all across North America. Whether you know that or not, it's the absolute truth. He's very famous and knows pretty much all the mushrooms. My ties with learning Amanitas come from him. As I said at the outset, the little contents of what we were going to talk about tonight said all this was being told from the standpoint of me, and I'm not a taxonomist. So why did I decide to do a somewhat taxonomic book with Jay? The reason is because I've studied evolutionary biology of fungi for 35 years, and I've worked on the evolutionary relationships of insects. I'm actually an entomologist. Evolutionary relationships of insects with mushrooms. Mushroom-feeding flies, they feed on nothing else but mushrooms and live inside mushrooms as those maggots that you hate. Yes, that's my dirty little secret. There it is. That's what I studied. So over decades, I decided I was going to focus maybe on one group of mushrooms. Maybe this group should have like poisonous species and non-poisonous species because maybe I'll see differences in the two groups. So I thought, oh, Ammonitas would be perfect. They're legendary for having, you know, hellishly poisonous species and edible species. And so talked to Jay about my idea and said, to be able to do this, I'm going to need to learn all the Ammonitas of North America. And I travel around a lot, so I have access to them, but I need to learn all the Ammonitas. And basically everyone says there's no one that can teach you all the Ammonitas but Jay. So Jay took me under his wing, and this is how I learned all of the Ammonitas from him. So there's one other person, and Jay mentioned him the other night, that I have to thank, of course, and that's the grand poobah of all the Ammonitas, and that's Tullis, seen here on the left. He's the world's authority, certainly the North American authority on Ammonitas. He's been studying them his whole life, and he literally knows everything about them. And yes, so it says there's so many species, barely enough time to name them all. The other guy on the right, Noah Siegel, quite an accomplished field mycologist and certainly well known for his photography. Says there's so many species, barely enough time to photograph them all. And he's become one of the real authorities on field mycology and has done a number of great books too over the years. So, and thankfully I have these sorts of people as my friends, so I can learn a lot from them. So, in any case, that's the end of the show. Thanks for your attention.